everybody, it's Mrs. Harbin. We're going to do our last video notes for section chapter unit 5. Okay, please make sure you can do these 3 things when we're done. Alright, always make sure to read chapter 11, sections 2 and 3 have what we're doing now. Okay, so what are we going to be doing? I'm playing this song for a reason, because when we're done, I want you to say what they're saying. So here's what you got to do when you're looking at chemical reaction. You got to decide what type it is. So here's our 5 types. Here's how you decide based on the reactants. Combination is 2 elements. Decomp is 1 reactant. Single replacement is an element and a compound. Double replacement is 2 compound. And combustion is a hydrocarbon and oxygen. So let's decide what type of reaction we have. Well, we have an element and an element. So this is a combination or synthesis. All right. So what do? You go get a periodic table right now. Periodic table. Have it with you. And say, okay, these are going to make 1 compound. So then on periodic table, sodium's +1, sulfur's -2. So we need 2 sodiums and a sulfur. Okay, that's just taking you back. 2 of these for 1 of those. First, you cancel the charge and make the correct formula. After that, you go back and put in coefficients. So we have 2 sodium, 1 sulfur, 1 sulfur balanced. Okay. All right, so our first prediction of products, and then you go back and balance it. Over here, we have element fluorine, element lithium. The only thing they could do is make 1 compound because it's synthesis. So then we go to the periodic table. Lithium's +1, fluoride's -1. Formula is LiF. That's what you write because you have to cancel the charge. Then you go back and say, wait a second, I need 2 of those. So you get 2 fluorines and 2 of those. All right, so combination or synthesis, you recognize because it's 2 elements, and then you use the periodic table to cancel charge. Okay, elements. Barium, remember, always put the positive 1 first. Barium's a +2 from the periodic table. Oxygen's a -2. It's BaO. So you write that in as the product that you're predicting it will be, and then, and only then, do you put in the coefficients. Let's see. I need 2 there, and then I need 2 there. Okay, so synthesis, 2 elements. Once you recognize, cancel their charge, then go back and put in coefficients. What are these? Well, let's see. 1 reactant, 1 reactant, 1 reactant, 1 reactant. These are decomposition reactions, all of them. Once you recognize a decomp, the ones that you'll have to predict, you break them into their elements. So here's a compound, and so you break it into mercury is one of the elements, oxygen is the other. After you break it up, then you don't forget whoops, I put the I in the wrong place. Alright, are either of these elements these? Well, there is the O, so I have to put the 2 next to it. Once you have the correct elements for decomp, you go back and put in coefficients. I needed 2 there, so I get 2 oxygen, and I needed 2 there to get 2 mercury. Okay, NH3, only 1 reactant. What's it going to do? It's going to break up into its elements. N's, nitrogens, and hydrogens. Then you see, oh look, there's the N, so you got to put 2 next to it. There's the H, you got to put 2 next to it. Then and only then can you go back and put in coefficients. So I have 2 N's over here, I need a 2. And I have 6 H's, so I need a 3. And so I have 2 N's, 2 N's, 6 H's, done. This is a decomp reaction because it's only 1 reactant. So I figure out the elements that are in it, break it down, check to see if any of them are Nafkulber. None of them are, so I don't put anything next to them. Now I put in coefficients. 2 aluminum, 3 sulfur on the left, I need 3 sulfur on the right, and we're done. Okay, this is one that you're going to see in the lab, so I thought I'd give it to you. This is 1 reactant because it's 1 big stinking thing with nothing, no plus signs. This is called a hydrate. What happens when you react to hydrate is you dehydrate it, so you get the magnesium sulfate and the water. Okay. Now we're going to do something about states of matter right now. But first, look, there's 7 waters in here. States of matter are what come after the substances. Okay, so I'm going to go back to this first reaction. HGO, if it's an ionic compound, I want you to put an S next to it unless it's in a double or single replacement. Okay. If it's a metal, I want you to put an S next to it unless it's the metal mercury, which is a liquid. If it's a diatomic, I want you to put G's for most of them. 5 of them get G's. All right, and oxygen is one of those 5, oxygen gas. Bromine is a liquid, and iodine is a solid. Okay, so let's try to put states of matter in here. Now this side over here, that's a covalent compound. I will tell you that that's a liquid. But this is an element. It's element nitrogen. It's diatomic. All the diatomics are gases except for bromine and iodine. Here's an element. It's diatomic. It's a gas. Okay, so 5 diatomics are gases, 1 diatomic's a liquid, 1's a solid. Okay, in this reaction, this is an ionic compound. Ionic compounds are going to be solid in decomp reactions. Aluminum. Aluminum is periodic table will tell you it's a metal. Metals are solid except for mercury. Non-metal. Non-metals are all solids except for the ones that are diatomic. Okay. And then finally this one, I'm going to tell you this is a solid. In a lab experiment you would see it was solid. Ionic compounds are going to be solid. Water is a liquid. Okay. Hey, this type of reaction is going to depend on an activity series. We did a lab with this. All right, here's the activity series of metals. Here's the non-metal one. What type of reaction? Element plus compound is a single replacement. So you have to see is lithium more active than silver. Here's lithium. Here's silver. I'll say lithium's more active than silver. So lithium's going to go in, kick out the silver. So Ag gets kicked out. Silver is a metal, so we're going to put a solid. When lithium kicks out silver, lithium has to make a compound with nitrate. Okay, nitrate has a -1 charge. Lithium from the periodic table has a +1, so you have to write LiNO3. Now, make sure it's a +1 and a -1 done. Check the charges; they canceled. Good. So now we got to put in states of matter. Lithium is a metal. Metals are solid. Here's the thing about single replacement. All the compounds in single replacement are aqueous. All right, all the compounds in single replacement are aqueous. All right, CO, CaCl2, element compound. You have to check if cobalt is more active than calcium. Let's find cobalt. There's cobalt. There's calcium. Cobalt cannot kick out calcium, so this is a no reaction. All right, single replacements are the only ones you have to look at the activity series for. Look, another single replacement. How do I know? Element compound. So you have to see if the element can kick out part of the compound. So you look to find chlorine. Is chlorine more active than fluorine? The answer is no, so this is no reaction. No reaction. All right, if there was a reaction, we'd have to cancel charge, put in states and coefficients. All right, oh look, it's an element and a compound. Must be single replacement. Element, compound. Is barium more active than gold? Well, let's see. I'm going to erase all these. Where's barium? Barium, gold. Barium can kick out gold. So we go back here and we say, all right, barium is going to hook up with sulfate. Well, sulfate is a -2. Barium's a +2 periodic table. So I have to write it as BaSO4. And what got kicked out was the gold. All right. States of matter. Gold's a solid because it's a metal. Barium's a solid because it's a metal. All of the solutions, all of the compounds in single replacement are solutions. So then I see barium 1, 1, gold 1, 1, sulfate 1, 1, done. Sodium is trying to kick out magnesium. Let's check. I'm going to erase this so you can see where's sodium. Sodium's right here. Is it more active than magnesium? It is. So sodium can kick out magnesium. The ones that are more active can kick out the other ones. So now sodium's a +1 periodic table, chlorine's a -1 periodic table. So I'm going to get NaCl because I have to cancel the charge. What happens to the magnesium? It gets kicked to the curb. See ya, Mg. Because magnesium's a metal, it's going to be a solid. Sodium's a metal, it's going to be solid. Compounds in single replacement are aqueous. All right. What else do I need to do? Well, I need 2 chlorines on this side, so I put a 2 there. Now I have 2 sodium, I need 2 sodium there. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine, 1 magnesium, 1 magnesium, done. Okay. Look, it's Mn, manganese, and Al, aluminum. I have to see if manganese is more active. Manganese is right here. It's not more active than aluminum, so manganese you cannot kick out something above you, so this is no reaction. So I don't even write the products, I just put no reaction. Okay, that was single replacement. Let's see what else we got. Look, it's a compound and a compound. In compound-compound reactions, it's double replacement. Okay, so you take the first and cancel charge with the second. So this is a +4, this is a -3. So we're going to have a Pb, the +4, and a PO4 with a -3. That is not equal 0. So I'm going to need 3 of those for a +12 and 4 of those for a -12. Okay. And then what do I have left? I have an H, which is a +1, and a Cl, which is a -1. and HCl. Okay. Now, then we have to put in coefficients. I'll start with lead. I need 3 leads. Okay. And then I have 3 leads. I need 4 phosphates. So I'll put a 4 there for phosphate. Okay. 4 phosphates. And then I'm going to need 12 hydrogens. So I put a 12 there. And so I have 12 H's, 12 Cl's. Okay. But wait, I need to change this to make it 12. So I'm going to put a 3. 3 times 4 is 12. Okay. 3 leads, 12 hydrogens, 4 phosphates. That was already a 3. And now it's balanced. Okay. Next one. Compound, compound. 2 compounds, double replacement. They do the old switcheroo. So the positive comes first. It has to go with the negative part of that. K is a +1 periodic table. F is a -1 periodic table. KF. And Mg is a +2. Sulfate's a -2. MgSO4. Okay. And then I go back and put in coefficients if I need them. I need 2 Ks on this side. 2 Fs, 2 Ks. 1 Mg, 1 Mg, 1 sulfate, 1 sulfate. Done. Okay. Over here. Compound, compound, double replacement. So I need the +2 magnesium to hook up with the -1 chlorine. So I need MgCl2. Why? Because I need an Mg with a +2 and a Cl and a Cl. So that's what makes that cancel charge. Calcium is a +2, carbonate's a -2. It's going to be CaCO3. And then 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. 2 chlorines, 2 chlorines. Done. Balance. All the coefficients are 1s. Okay, so step 1 for double replacement, cancel charge, cancel charge. If it comes first on this side, it better be coming first in these compounds. So calcium's listed first, magnesium listed first. Okay. Now, the thing about double replacement is the states of matter. All of the reactants are aqueuses. Okay. In a double replacement, we start out with all AQs. Double replacement, all AQs. Double replacement, all AQs. In the products, one's going to be an AQ and one will probably be a solid. So let's look at what is a precipitate. It's insoluble, it's a solid, it's going to be a solid or a down arrow or a solid. AQ is aqueous, dissolved in water. S is solid. So we have what are called solubility rules. Here's what they look like. So this is saying that anything that has nitrate, acetate, or chloride in it is going to be soluble. Okay? So let's look at these. Do we have any nitrates? Oh, here's a nitrate. So that's going to be AQ because nitrates are soluble. Let's see. Anything that has sodium, potassium, or ammonium in it will be a soluble thing. Oh, here's potassium. That's going to be soluble. Here's ammonium. That's going to be soluble, AQ. All right. Here's, let's see. Oh, here's a nitrate. That's a first rule, AQ. Okay. What does this mean? Anything that's a chloride, bromide, or iodide will be soluble unless it's a silver chloride, mercury chloride, or lead chloride. All right. Okay, here's AgBr. Bromides are soluble unless there was silver, mercury, or lead. This one's with silver. Solid, then it's going to be a precipitate. Okay. We'll practice more of these in class, but anything that says soluble means AQ, aqueous. Precipitate or except insoluble means solid. S. Insoluble. Okay. All right. So you have to be able to predict products for all types of reactions. Make sure you know that metals are solid unless mercury, because that's a liquid. Make sure you know your diatomics are gases except that bromine's a liquid and iodine's a solid. Ionic compounds are going to be solids unless when they are in decomp and combination reactions. Ionic compounds are going to be aqueous as reactants in double and single replacement. Ionic compounds are going to be aqueous except in the products for double replacement. Okay, please make sure to know these rules and we'll keep practicing. Remember, combustion gives you gases. So let me go back to combustion. I think we got to go forward. Okay. So here are 1, 2, 3, 4, 5, 6, 7, 8 reactions. Okay, I'm going to do 3 of these for you and we'll do the rest in class. I'm going to do this one. Look, it's a hydrocarbon and oxygen. This is definitely combustion. Here's what I need to tell you about combustion. Combustion, you always get the same products. Those products are CO2 and H2O. What did you find out about combustion? Always get gases. Alright, so we get a gas there and a gas there. And then all we have to do is balance it. So I'm going to put I was going to put a 6 and it turned out to be, alright, so we have 6 C's. 6 times 2 is 12 H's. And now I have 12 plus 6 is 18 oxygen here. So I need to put a 9 in front of O2 to get 18 oxygen. Alright, hey, oxygen's a gas. Now this one, I wouldn't expect you to know. But this is hexene. That's going to be a liquid. But I'll tell you that one. Okay, so I'm going to do one more here. I'm going to do this one here and here. Okay, so this is a compound and a compound. Compounds. Alright, so we have to do the switcheroo. H needs to go with Cl. H is first, plus 1. Cl second, minus 1. HCl. Plus 1, minus 1. Copper has to go with sulfur. Copper is a plus 2 in this compound. Oh, escape. Plus 2 in this compound. Sulfur is a minus 2. So we have Cus. Now, this is double replacement. The ionic compounds are aqueous and double replacement. It has reactants. But we have to check the solubility rules for the products. Whoops, went too far. Okay, we're looking for something with sulfide, S in it. Sulfides are insoluble, meaning they're precipitates, unless they're with group 1, ammonia, calcium, magnesium, or barium. So let's see. This copper with sulfur is going to be a solid precipitate, and this is going to be an aqueous. All right, we did 2 of them. I'm going to move on, and we'll practice some more. Here are some keys to success. I'm just checking. We are ready to start our review. Keys to success. What you want to do for all of these is cancel charge. Use your periodic table and your ions. Cancel charge. All right. Decomposition. Don't forget to look for diatomics. All right. Single replacement. Use the activity series and cancel charge. Double replacement. Cancel charge and look for a precipitate. Okay. So to review, recognize the type of reaction. Cancel charges for ionic compounds. Use activities for activity series for single replacement. Solubility rules for double replacement. In combustion, it's always this. You can also write it like this. Alright? And they're always going to be gases. Gas, 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 gas. So here's what I hope you're saying right now. Suddenly, I see the book connections. I see how to do all these things. And peace out, folks.